Geometry also has been updated. Next, we're going to go for the model. Edit. Depending upon your system requirements, again, it will take a little bit time. So the model has been opened. So before performing the meshing, or you give the thermal boundary conditions, before that we have to assign the geometry. Okay, you assign the material to the geometry. What kind of material you're going to assign? So click on it. We'll assign the material titanium alloy. From the material section, you see in material, when you click on select geometry and click on turbine bed, we'll be having a material, and there will be assignment, and we have to select titanium alloy because we have deleted structural state. We'll be only remaining with titanium alloy. If you did not delete, you can have both, but you should select titanium alloy. Okay. Next, we have assigned the material. Next, what are we going to? We're going to perform the meshing. You can simply right click on mesh and give generate mesh. What is happening? You see the mesh is very coarse. It is not fine. The mesh is very coarse. So coarse mesh is always an avoidable situation. We have to never should make a coarse mesh. Okay, because it gives a lot of errors. It won't give accuracy. Our desired results won't be. So for that, what I have to do again? Go to insert, click on sizing. Here you select the geometry. Click on this body and you select whole body. Apply element size. Choose element size and give element size as 0.005. Okay, and click on right click on mesh and generate the mesh. Now what we are going to give the geometry a fine mesh, not a coarse mesh. We are going to give the geometry a fine mesh. So 0.05. So depending upon your system requirements, your meshing will be fast or slow. But this mesh still looks a bit coarse. I'm going to go with 0.001. Let's see. And I'm going to click on generate. This may take a bit of time because we are given a very coarse, we are given a very fine mesh sizing. So it takes a bit of time. So you can see the meshing is done now. It took a bit of time. But depending on your system requirements, if your CPU processor is slow, you can go for the sizing. You can go for the sizing which is 0.03 so that the meshing will be quick. How you can see the meshing is unstructured, but still it is very fine. For our simulation, we don't require any fine mesh. Making fine mesh in 3D for a 3D body, it takes a lot of time and experience. For now, for our simulation, our fine unstructured mesh is satisfactory. So as meshing is done, the next thing we are going to do is we are going to give the thermal boundary conditions. For that, right click on steady state thermal, click on insert and click on temperature. Okay, you can rename this as blade temperature. Click on it and geometry, click face, click on this face, control, again select all the three faces of the turbine and click on apply. You should see three faces. Now temperature you will give, as you see, turbine blade, turbine section in a jet engine will be after combustion. So the turbine blade will be experiencing more temperature. Okay, so the temperature will be around from 1200 to 2400 Kelvin. So here we are going to give just 1400 degrees Celsius. Next one, again we have to select for the root, right? So again select all the geometries, all the faces, the root section. Click on apply. Root section's temperature will be somewhere near 450. Okay. So we'll see how the temperature variance at the root is happening. As the temperature the turbine blade is experiencing more temperature and the root temperature is very less compared to it. We will see at the intersection of this how the temperature is varying. So we can rename this as root temperature. Okay. Now we have given the boundary conditions. Now right click on solution, insert thermal. You can give temperature. Again insert thermal total heat flux. Insert thermal direction heat flux. Now I've given everything. Now what you have to do, you have to click on solve. Our last step is we are going to solve this. Okay, now that our simulation is finished, let's check the solutions. Click on temperature. You see, you can select on animation. Click on this. You can see the temperature, minimum and maximum temperature variation here. You can click on total heat flux. Click on it and select the play button animation. You see near the root section, we observe a minute total heat flux is happening. Be happening all over the root, at the intersection of the blade and the root. This is your total heat flux. Similarly, you can check direction heat flux on animation. It will be very minor, depending upon the boundary conditions. So that's it of this experiment. Thank you.